All right, Exponents Plus. I kind of like this title, Exponents Plus, because really it's about exponents negative, but plus kind of means, like bonus, like tough stuff, so that's cool. But really it's kind of ironic because really we're dealing with exponents negative. I'll show you what I mean. 7 squared equals 49. This should not be surprising. You should know this. You should love this. This should make tons of sense to you. This might not make as much sense, but this is all you got to know. 7 to the negative 2 equals 1 over 7 squared equals 1 over 49. Don't fight it. Don't fight it. It's just the way it is. And it kind of makes sense too, right? You think of 7 to the negative second equals 1 over 49. 7 to the negative 1 will equal 1 over 7, right? 7 to the 0 equals 1, 7 to the 1 equals 7, and 7 to the 2 equals 49. So each step you take, you're multiplying by 7. Think about it. It's true. It's not scary. It's just the way it is. It's just the way mathematicians have decided to do exponents. And it actually kind of makes some sense. Just think about it as flipping into the denominator and also thinking about it as walking up a ladder or walking down a line, just multiply by 7 each time, which kind of makes sense because that's what exponents are all about. All right, let's do some problems. Question 1, which of the below is equivalent to the following expression? 7 to the negative 2 over 7. Well, let's just think about this as 7 to the negative 2 over 1 times 1 over 7. That kind of makes sense, right? Because you can just separate these out into their component parts. That's not too bizarre. You don't have to do it that way, but I think it's helpful to teach you that way. Okay, so this is all about flipping it to the denominator, so this becomes 1 over 7 to the second. This is the key move. That's the key move. You gotta learn it. Negative exponents, flip it to the denominator. Don't fight it. It's just the way it is. That times 1/7 will give you 1/7 to the third, which is 343. If you don't know 343 is 7 to the third, well, now you do. You should just kind of learn this, right? Because you're gonna know it eventually, right? You're a high-performing kid. You're academically ambitious. You know that 5 squared is 25. You know that 6 squared is 36. You know that 7 squared is 49. Well, you should know that 7 to the third is 343. It should just be something that you know. You'll learn it eventually, so you should learn it now. 343, there you go. Now, I'm not saying go home and learn all the cube roots of all the numbers from 1 to 10, but you're going to know them eventually, so it shouldn't be that scary that you have to do 7 to the third power. You get 343, the answer is A. We're good to go. Question 2 is a simple problem that many people get wrong. 3, so let's read it first, I guess. Which of the below is equivalent to the following expression? 3x squared all to the third power. Well, just think about it, right? If 7 to the third equals 7 times 7 times 7, which, it's pretty obvious, right? This to the third is just going to be 3x to the fourth times 3x to the fourth times 3x to the fourth. So if you have 3 times 3 times 3, that's 27. So these answers are kind of silly and they're gone. And now you have 27x to the 7th and 27x to the 12th. Well, what should we do? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's obviously going to be x to the 12th. If you think about it, x times x times x times x times x, and so on, will get you x to the 12th. It's not going to be x to the 7th, it's going to be x to the 12th. We're good. Okay, question number 3. The distance from the Earth to the Sun is about 93 million miles. What is this value written in scientific notation? Ah, there's a term for you, scientific notation. If it doesn't make sense to you after I talk about it for about 2 minutes, then you should Google it or search for it under Khan Academy or search for it under YouTube or, just search for it and learn about it and enjoy it. It's an 8th grade Common Core standard, so you are going to learn about it next year. And it's kind of all about the way scientists write numbers. No, that's a joke. That's not how scientists write numbers. I don't know why it's in the 8th grade Common Core. I don't know why it's on these tests. It just kind of is, and we have to answer the math problems that are given to us, not the math problems that should be given to us, so we kind of have to deal with it. Okay, so let's go through it. Scientific notation, as you can see from these distractors, and the correct answer is in there somewhere, is all about something times 10 to a certain power. 10 to the 0 equals 1, 10 to the 1 equals 10, 10 to the 2 equals 100. So you can think about it as 10 to a exponent. That number in the exponent place, that number like up there to the right, is the number of zeros after the 1 to follow. So 10 to the 0 has 0 zeros, 10 to the 1 has 1 0, 10 to the 2 has 2 zeros, and so on and so on and so on. Okay, so what's 93 million? 93 million is written like this, right? Because a million is before the comma of 3 zeros and another comma of 3 zeros, because it's units, tens, hundreds, thousands, 10,000s, 100,000s, millions. So there we go, 93 million. So you're like, okay, so it's gonna be 9.3. Now this is important. The number to start the scientific notation form has to be between 1 and 10. So it's 9.3. You don't say 93, you say 9.3. Why? That's the rule of the form. So, okay, so right away, we know that 93 times 10 to the 7th, that can't be right, and 0.93 times 10 to the 7th, that's not right. These values might be wrong, but just the form of the notation is wrong. Okay, so you have 93 times 10 to a certain number. So you're like, okay, I know how to do this because I know how to count zeros. I'm going to count zeros. I'm going to count 1, 2, 3, 4, 5, 6. I count 6 zeros, and my answer is going to be A. That is totally wrong. Why? Well, let's just think about it. If the decimal point is here, and we're going to take a journey with this decimal point, how many jumps do I have to go? 1, 2, 3, 4, 5, 6 takes me to there, but I'm not going there. That's 93. I'm going here to 9.3. So how many jumps is that? 1, 2, 3, 4, 5, 6, 7. I have to multiply it by 10 to the 7th. I need 7 zeros to get 9.3 to go to 93 million. That's the last jump that everybody forgets. And that's why, you know, math teachers like me put the distractor in there as 9.3 times 10 to the 6. Because I want to fool you. And the people on the SHSAT will want to make sure they're, you know, making a good distinction between those who really know it and those who don't really know it. So that's the kind of distractor that they're going to include too. Don't fall for it. Know that the decimal point has to travel 7 spaces in a question like this, and we're good to go. Question 4. An average dust particle has a radius of 2.3 times 10 to the negative 6 meters. What is this in value in standard notation? Hey, okay, so like we said before, the number in the exponent place is the number of zeros. Well, what if you have 10 to the negative 1? That equals 0.1. It's all about moving that decimal point. All about moving that decimal point. 10 to the negative 2 equals, because you move it 2 spots. Okay, so what do we have when we have 2.3 times 10 to the negative 6? We're going to move that decimal point 6 spots. Why? Because it says to the negative 6. All right, 1, 2, 3, 4, 5. Can we make it one more? Yeah, all right, we're not that tired. 6. All right. Okay, there we go. That's our answer. That's how you do it. Note again that many people are going to say, oh, negative 6, that must mean that there are 6 zeros between 6 zeros between the decimal point and my first digit. That's not true. Look at it. We moved it 1, 2, 3, 4, 5, 6. So it's not 6 zeros between the digit 2 and the digit 3 and the decimal point. It's only going to be 5. Why? Because one of the jumps was from 2.3 all the way back over. All right, so we need 1, 2, 3, 4, 5 zeros, and we can count to 5. However, on the test, you're going to be working for a long time, and all these numbers are going to get blurry and all going to blur together. So make sure you have good stamina and ability to concentrate throughout the entire process. Let's count. 1, 2, 3, 4. That's not right. 1, 2, 3, 4, 5. Yeah, we're good to go. Question 5. Which of the below is equivalent to the following expression? X to the negative 2 all over x to the negative 3. All right, let's break it apart to begin with. X to the negative 2 over 1 times 1 over x to the negative 3. By now we know, we're not scared, we know this is going to be 1 over x to the second. But what do you make of this guy? All right, short answer is it becomes x to the third up there. Times 1, and then we do x cubed over x squared. 3x's over 2x's just leave us with x. So that's our answer. All right, now let me explain a little bit about how this jump makes sense, because you might be like, oh, I'm just going to remember it. Well, that's fine. If you just want to remember it, that's cool. That'll get you through the test. If you want to kind of take a journey with me to understand why it kind of makes a lot of sense, well, let's do it. It might be worth your time. Okay, 1 over x to the negative 3 equals 1 over x to the third, right? Okay, think of this as a division problem. 1 divided by that. So that's going to equal 1 over 1, or just 1, right? Just 1, all divided by 1 over x to the third. Now we remember this from 6th grade. What fun 6th grade was. 6th grade was awesome. Keep, change, flip. Well, I'm going to keep 1 over 1, which is 1, so I'm just going to keep 1. I'm going to change this to a multiplication. Flip this. Look at that. That's fun. That's how you get from there to there. Or you can just be like, I'm seeing it in the denominator, I'm taking it to the numerator. Whichever way you want to do it, you can do it both. We're good. Question 6. Now we're really rolling. Which of the below is equivalent to the following expression? All right, well, we know how to do this. 2 to the negative 2 over 1, all times 1 over 2 squared. Okay, well, let's flip that guy down there, and we got 2 squared times 1 over 2 squared. That's 2 times 2 times 2 times 2, so that's going to equal 1 over 2 to the fourth. What are my answers? Do I have 2 to the fourth down here? No, but I have it as 1 over 16, right? Because that makes sense. 1 over, this is 2 times 2 times 2 times 2. So that's 4 times 4. You can think of it 4 times 8 times 2 again. Any way you do it, you're going to get 1 over 16. We're good to go. Question 7. Which of the below is equivalent to the following expression? We've done this before. 2x to the fifth all to the third. Okay, so 2x to the fifth times 2x to the fifth times 2x to the fifth. All right, so it's going to be 2 times 2 times 2, which is 8. So this is wrong and that's wrong. And then we're going to have x. And what was our rule again? Well, now, some people might say, just because we did 2 times 2 times 2, which is 2, 4, 8, we should do x 5 times 5, which is 25 times 5 again, which is 125. That's not right. The answer is x to the 15th. Think about it. X, 5x's times 5x's times 5x's. You're just going to add them all together, right? X times x is x squared, 3x is x cubed, 4x is x to the fourth, 5x's is x to the fifth, 15x's is x to the 15th. You might be multiplying the coefficient, the 2. 2 times 2 is 4 times 2 again is 8, so you get 8 there. But the x's you just add together, and we're good. Question 8. Which of the below is equivalent to the following expression? 5x cubed, oh buddy, all to the negative 2. Oh my gosh, now people start getting anxiety. They're like, I don't know how to do this. But if you have 7 to the negative 2 equals 1 over 7 squared. This shouldn't be any different. It's not scary. It's just 1 over 5x cubed all to the second, which is just equal to 1 over 5x cubed times 5x cubed, which is 1. 5 times 5 is 25. X to the cube times x to the cube is x to the 6. We're good. Question 9. Which of the below is equivalent to y? Y times 2x to the fifth equals 32x to the 10th. Okay, that looks ridiculously tough. How are we going to do this? Well, if we had 5y equals 30, we'd divide each side by 5, and we get y equals x. So the same principles apply here. We're going to divide each side by 2x to the fifth, and we're going to get our y. Okay, not too scary. All right, so what's 32 divided by 2? Well, That's going to be 16. All right, so a and b are gone. And what's x to the 10th divided by x to the 5th? Well, some people might say, oh, it's x to the 2, right? Because 10 divided by 5 is 2, but that's not how it works. If you have 10 x's, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you divide that by 5 x's. Well, x divided by x cancels out. That cancels out. That cancels out. That cancels out. That cancels out. What do you have left? You have 5 left. We're good. And finally, question 10. What a journey it's been. Which of the below is equivalent to the following expression? All right, let's separate them out. X to the negative 7th over 1 times 1 over x to the negative 5th. We're going to look at our negative exponents and flip them around. We're going to multiply the numerators and multiply the denominators. And now we're going to say, well, 5x's over 7x's, that's going to cancel out all the 5x's, and we're going to have 2x's left down here. Think about it. Draw it out if you need to. Don't fight it. The answer is B. We're good to go.